Okay, so this is required practical number 7, measuring reaction time. Okay, so before we start, you all need to redo your control variables. So, can you get a green pen and a ruler, and you need to redraw a table in your book that looks like this. So you can have variable, effect, control. When you're doing your control variables, you need to make sure that you say what could change, what effect it would have if you didn't control it, and how you control it. So one of the first things we did was when you're dropping it, you made sure that the ruler was at the top of your thumb. So that's how you control it. So if I write ruler at top of thumb. So the variable is ruler position. Now, if you change the ruler position, it's going to affect your reaction time. Okay. Another control variable, so something you kept the same every time. If you were doing music, the variable you write down here, so you need to write this in your table. If you did music, you'd write music in this one. Okay, so you can pause the video and write down what I'm saying as I say it. So music, or the type of music, sorry, so the type of music, effect it's going to affect your reaction time. So the way that you control the music is you make sure you use the same song every time. So in there, same song every time. If you did dominant hand and non-dominant hand, then that's the thing that you're changing, but there's not really anything that varies when you do that. Another control variable is position of hand. Effect, reaction time, and the control. So you can get these from the blokes video that I put up, which I can put in the comments, and you can re-watch that one as well. Is position of hand, reaction time. Your hand had to be on the table, so arm on table with hand over edge. If you didn't do dominant and non-dominant hand, one of the things that you'd need to make sure you kept the same each time was the hand that you're using. So if you're doing music or caffeine or heart rate, you still need to make sure that you're using the same hand of that person each time. So you'd say type of hand, effect, reaction time, control, dominant, the person uses the dominant hand every time. Something else is the which way around the ruler is. So again, variable, ruler, effect, reaction time, control. Same ruler, and the ruler needs to be 0 down, so the 0's on your hand. Something else you can keep the same. You need to catch the ruler, the number side of the ruler needs to be on the same side as your thumb. So when you put the ruler in, if I get this one, I'll show you, because they were wooden rulers, you can't see through them, you would catch it from the 0, you catch it here, and when you take your results, you take it from the top of the thumb. So variable is position of ruler catch, effect is going to affect your reaction time, control, you read the ruler from the top of the thumb, okay, not the top of the hand, the top of the thumb. So all of those, you need at least 3 control variables written down in your table. Okay, so let's start with person number 1. Your reaction time. If you drink caffeine, nerves work faster, boost energy and neurons. If you're listening to music, the slower your reaction time. Caffeine speeds up neurons and work faster, reaction slower. Yeah. You need to put this into kind of like a statement, which you have. It's like a prediction, but you don't say I think, you put it as a statement. So human reaction times will be affected by listening to music because if you drink caffeine, oh sorry, not caffeine, you did music, didn't you? Because the music will distract you, and so you're not focused on that one thing, something like that. You said listening to music, which is right. The measurement you're going to measure on the ruler, yep, in centimetres. So you've got your unit, that's what that is there, okay? Control variables, all of these are really good. Just put them into a control effects table, the one I showed you just now. Method. The person being tested should sit with their arm resting on the edge of the table. This should stop, yep. Hold the ruler vertically between the thumb and forefinger, make sure the zero end of the ruler perfect level, and then let it go without warning. The person tested should catch the ruler as quick as possible. That's a control variable there, without warning. Okay, so yeah, you can put that in your table as well if you want. Reaction time is measured by the number on the ruler where it's caught. The further down it is, the higher the number, the slower the reaction time. Yep. Repeat the test several times. Can you put a number on it? So 3 times. And then calculate the mean distance the ruler fell. The person being tested should have caffeine drink or listen to music. And you've still done it anyway. So you've said 300 mils after that many minutes, and then repeat the steps 1 to 5. Perfect. Obviously we weren't doing caffeine in class, but if we were to change this, we'd write the person being tested should have the music on at maybe 10% after, and then repeat steps 1 to 5, and you'd say your interval, or you increase each time you do the test, you increase the interval by 10. So 10, the word is interval, the distance between each volume increase. So you'd say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100%. Control variables, make sure that it's a fair test, or you've said those up there, so you don't need to say it there. Repeat the test several times. Think what I mean. Too much caffeine causes unpleasant side effects. The person being tested should avoid drinking any more caffeine. Yeah, that's a really good point. That is about ethics, and it's about evaluating your method and seeing if is it ethical to make people who are 15, 16 drink caffeine when they're not allowed to buy it yet. Okay, up the top you've got, you know that your independent variable goes there and your dependent goes there, but you need to write down what the independent variable is, and you did that here. Okay, so music, okay, or music in percent up there, and then your dependent variable is reaction time, and the units is centimeters. Okay, so centimeters, or you either write the centimeters or you write the times that you converted them into. You didn't say in your method that you were going to convert your means into reaction time, so I'd add that bit into there. 20%, 50% not listening, music. It'd be better to put that not listening 10, 20, 30, 40, but it's fine as it is. Explain why each experiment was carried out more than once. Experiment was carried out more than once to make it a fair test, trustworthy. A fair test isn't if you do it more than once. A fair test is making sure that you keep everything the same except the independent variable. A fair test is about control variables. Carrying it out more than once means that it's reliable. All of your results should look similar, like 17, 17, 25 looks a bit odd, so you might want to repeat that one. These look okay, so 15, 19, 11, they're all quite accurate. They're not precise, as in close together, but they're quite accurate. They're all around the same number. So reliable means, if you did this again, would you get the same results? And by doing it 3 times, you can see if there's any anomalies or outliers in maths, and then discount them in your mean. So you don't count them up in your mean, you'd redo maybe number 25, so you'd redo that one again. What is the advantage of working out the means? Well, I've just said all that there. Use a graph and axes. So your graph, volume of music, percentage, music reaction time in seconds. Yep, you've got the right amount of distance between each one of these. However, these ones between there and there, and 0.5 and there, you've got different amount of space. So each, when you do the axes, they have to be the right distance apart. Okay, I'm going to turn that around. So that one is 3 centimeters, near 3 centimeters between those two, whereas that one's only 2 centimeters. So make sure you do that really irritating thing where you count out each little square and put the lines on first. Your plots look good. Try and do it a bit more curved. It's fine, but it's a little bit sketchy, as in you've scribbled up and down. What can you say about the effect of the independent variable and the dependent variable? The effect of the independent, the music. So rather than saying the effect of the independent variable, just write the music, okay? The effect of the music, or the percentage of volume of music. As the volume of music changes, varies throughout the dependent variable. Reaction time changes when the independent variable changes. As the volume is distracting, my results prove. You need to do like an statement, which is like faster, slower. Your results show the higher the volume of music, the slower your reaction time. So that's your independent and dependent. So it's how one affects the other. As the volume increased, the reaction time increased. Okay, and then you've got a reason for that, which is what you put here. The louder the music, slower reaction time, which is perfect. And it's because it's distraction. Yep. How does the reaction time change as the independent increases? In your answer, reference to results. So this type of question can be worth 3 points. So if you do it as a PEE, so the point is, the higher the music, volume of music, the higher the reaction time. So that's point. Evidence at 20%, the reaction time is 0.16, I'm guessing from that. At 100%, the reaction time is 0.27. And then evidence, this proves that the louder the music, the slower the reaction time, because it's proving as a distraction. PEE will get you all 3 of those marks, okay? It stops you waffling as well. I know waffling is sometimes good, but be really concise in your answers. Do your results support your hypothesis? Yes, the louder the music, the slower the reaction time. Yeah, perfect. How could you improve your experiment? Improve the accuracy and precision of my results. I believe I could repeat the experiment with somebody else that's more reliable. Or repeat readings from your results that weren't precise, so close together. So like 25. How could you improve your experiment? Accuracy and precision. So precision means putting them close together to make it more precise. Repeat results that aren't close together. Accuracy. I think your results are quite accurate. But and you did it all correct. How could you improve the experiment? Accurate. You could say something. I don't know. I think that's probably just writing down all those control variables. That would make it as accurate as it's fine. But possibly mentioning a new control variable. If you did music, then saying that the song was the same every time. If you didn't already do it, make something up that you didn't do. Say you didn't do it and add it in. Write down one safety consideration. Safety is about, should we let 16-year-olds drink? Oh, that's ethical. Sorry. Safety. Safety. If you watch the end of the GCSE Science 1 to 9 required practical video, it will go through the answers for these ones here. Okay. Reaction time could change as you talk to someone. What I think will happen, reaction time will be longer. This will happen because you become more concentrated on the subject of the conversation. Yeah, that's right. That's a really good hypothesis. I like that. Independent talking to someone or not talking to someone. You could say distraction. The time it takes to react. Reaction time in centimetres. Control variables. Height of the ruler. Make a person time to prepare. Launch surprise. Yep. Make sure the height of the person. Thumb height. Yep. Sit upright on the table. Perfect. Dominant hand. Nice. Like all of these. These need to be in a variable effect control table like I showed you at the start of the video. Work with someone. Hold out with the gap between thumb and finger. Partner holds ruler level with the 0 at the top of the thumb. Partner drops a ruler without warning. Catches it. The number level with the thumb will be recorded in the table. Repeat 6 times. Repeat 3 times. Okay, so repeat 3 times. Have you said that the person's going to be talking? No talking. So then what you need to do is say, now repeat steps 1 to 6, providing a distraction of talking to them. Okay, so that's what you need to put in there. When you're finished, then do step number 8. Calculate the mean time, the mean reaction time in centimeters, and use a conversion table to turn this into a time in seconds. And then those can be compared, can't they? Okay, I think that's good. Over. Reaction time, centimeters, volume, music, perfect. So you've changed your independent variable. You didn't do talking to someone. Everything else is fine. If you put music in this bit and music, if you rewrite your hypothesis to say music, everything else is okay. Explain why each experiment was carried out more than once. Each experiment was carried out more than once to see if the results are still the same as before. Just finding out the mean. You can find reaction time. If you watch video number 1, I'll explain how to do all of that bit there, and on the next page as well. And if you go back and watch the GCSE Science Biology video, which I'll put in the link below, then you can work out how to answer these questions as well. Your graph, 10, 20, 30, yep. Is that what you had in your results table? Yep. 0.05, yep, that's all perfect. Volume music in percent. Put the percent at the bottom rather than on each one of those. And seconds. It needs to take up 2/3 of the axes, otherwise it's perfect. Okay? You won't get the marks in the exam if it doesn't take up 2/3 of the axes scale. Okay. Reaction time will decrease when you drink Coke. That's really good. What I think will happen is the reaction time will be longer. This has happened because you become less concentrated. What you said, reaction time will decrease when you drink Coke. That means it gets faster. And this says the opposite thing. A hypothesis, you don't write I think, you just put the reason behind it. So reaction time will decrease when you drink Coke because it's got caffeine in it, it's going to make your nerves react quicker. That's what you write into all of this here. So I'd like you to rewrite your hypothesis, please. Independent variable, drinking Coke, not drinking Coke, so caffeine. So having caffeine would be your independent. Dependent variable, time takes to react, yeah, in centimeters. Control variable, the height of the ruler drops from thumb height, sit upright, arm on table, dominant hand. Good. I'd like that put into a control table, please, like I showed you at the start of the video. And then this is exactly the same as person number 2 because you work with them. So if you just watch video number 2, you'll see how to finish that bit. yeah, and if you just work with video number 2, it'll help you. Alright, read back through that one. Your graph isn't finished, but your axes is good. And even distances between spaces in the bars, that's really good. Just finish it off, please. Take your name off. Okay. Human reaction times are affected by if they are listening to music. Music can distract them. Yep, perfect. Hypothesis, really good. Hypothesis. So the volume of music. Yep. Can you put that you're going to do it in percentage? Measurement of ruler. Yep. Units on it. Okay. So include units. Always measure the thumb drop. Always drop the ruler on top. Yep. Can you put that into a variable effect control table at the start of the video, please? Find a partner. Sit down at the table with your forearm resting on the table. Now your hand coming out of your hand. Your hand coming out of your head. What's that supposed to say? The fingers should be open to catch really quickly as you can. Repeat the steps 3 times. And calculate time. Repeat the step 3 times. Okay. If you listen to the method from video number 1, you need to rewrite your method step by step, okay, so that you get some valid results. Because at the moment this will not give you valid results. You need to say about having a mean, it needs to be numbered, so I'd like you to redo that in green pen, please. This is fine, okay. If you watch the number 1 video, it tells you how to do these bits as well, okay? Tells you how to do all of that. And you haven't finished your graph, so that needs doing as well. Human reaction times are affected if they are listening to music. Good, I like your hypothesis. Volume of music, and centimetres, you've done the units, well done. Volume, can you put it in percent, please? From the top, yep. They're really good, but it just needs to be in a variable effect control table so that you get all the results in the exam. Okay, you've worked with the person I've just marked, so video number 4, and I've told them that you need to watch video number 1 and see how they've done their method, and you need to do a really similar method. So step by step, saying you're going to repeat it 3 times and calculate a mean, and then use a conversion table to turn it into a time. So you've missed off quite a few steps here that you need to do, okay? Reaction time in seconds, hand type, good. When you get onto this bit, watch video number 1 and it will show you how to answer all of the section 2 stuff. Also, number 5, sorry, you haven't finished your table, your results, your graph, so you need to do that as well. Hypothesis is the okay, you've just told me what hypothesis is, not what you've done in your results, okay? You've looked up what these words mean, but applied it to your experiment. So, human reaction times, okay? You've done human reaction times against the volume of music. That's what I wrote down in your results. So, your hypothesis needs to say, human reaction times can be affected by music because the music can distract them, okay? So, sorry, can you say volume of music? Independent variable, you're going to change the volume of music in percent. Dependent variable, reaction time in centimetres on the ruler is what you write here. Control variables, watch the start of the video and draw me a control variable table. Watch video number 1, listen to the method and write your own method, please, step by step. Then the same, listen to the rest of video number 1 and it will explain how to do each one of these ones.